So today we're talking about adding and subtracting rational expressions. So before we start to think about rational expressions, what I'd like us to do is I'd like us to just think about rational numbers, so fractions. So if I say, for example, I have 5 over 6 minus 3 over 8, right? So when I'm dealing with adding or subtracting, it's a little bit tougher because what we need is we need to have the common denominator right there. Okay? And there's a couple different ways we can do this. Lots of times students will just want to multiply the 6 and the 8, and that's perfectly fine to get us a common denominator. But when we're working with rational expressions, we want to look for not just any common denominator, but the lowest common denominator. Okay? We want the smallest possible number to work with. So if I think about a common multiple between 6 and 8, the smallest one is 24. Okay, so that's my least common multiple. So I'm going to do whatever I need to do to make 6 into 24. So here I'll multiply it by 4. Okay, and whatever happens on the bottom also happens on the top. Okay, on the other side with our 8, we know, okay, 8 times 3 is 24, so that 3 has to be multiplied on the other side as well. So when I'm looking at this, my next step, of course, is to go, okay, well, 5 times 4 is 20. Over 24 minus 9 over 24. And then for my final answer, I know I get, okay, 20 minus 9 all over 24. So our denominators never change. And then I get 11 over 24. Okay, so once my denominators are the same, it doesn't change. But what I can't do is I can't add or subtract until my denominators are the exact same number, both 24. Okay, so when we're dealing with rational expressions, so not just fractions, but things with x's and stuff in them, my first step hasn't changed. My first step is always, always, always to factor. Okay, once we've done that, we need to find that lowest common denominator. Okay, once we find out, we need to actually make them have common denominators. So both rational expressions need to have the same thing on the bottom. And then, as usual, NPV, and then solve and simplify. Okay, so our last step, solve and simplify, just like always. Okay, and as we go through a few examples, we'll realize that, okay, this step here, finding that lowest common denominator, that is by far the hardest step. That's the trickiest one for us. Okay, so let's start with some nice easy examples though. So if we do something like this one, we have 2x over x and x minus 1 being added with, say, 4x minus 1. Okay, so when we look at this, we say, okay, is everything factored? Yep, we're ready to get into looking for our LCD. So for our lowest common denominator, we have to look at both denominators. So on one side, we have the x and x minus 1, and on the other side, we have just an x minus 1. Okay, so I need something that I could make both of these multiply into. Okay, so I know for sure x plus 1 will be included. Okay, and then when I look at this, I know, okay, I've got to have the x in there as well. Okay, so it takes some practice to be able to look at it and find it, but we'll get there. Okay, so if we look at our first rational expression, this already matches up with our lowest common denominator, so I'm not going to multiply that side by anything. However, on the other side, everything needs to get. Okay, so when I look at this, I get to say, okay, this is equal to 2x plus 4x all over x minus 1. Okay, and then I know for my end, I want to see if I can solve it and simplify. So if I want to see if I can simplify, I should be factoring it as well. Right, so 2x plus 2. Oh, actually, sorry. For simplifying, I know, okay, 6x over x x minus 1. And then I'd look at this and I'd say, okay, well, I can divide x out of each side. So I just get 6 over x minus 1 as my final answer. Okay. Lastly, I know I need to find those NPVs, so I want to do that before anything gets crossed out. So I know x cannot equal 0 or positive 1. Okay, and I would need both of these to have a correct answer. So if I look at something a little bit different, okay, something else I could do maybe is like this one here. I have negative 6x squared plus 5 over 4x squared plus 3 over 6x. Okay, so first things first, is everything factored. The only thing that we could maybe factor is my first numerator, but I see nothing common, so yep, can't deal with that. I want to move right into looking for my LCD. So if I have a 4 and a 6, what I want to do is I want to think about those numbers and what is my LCD between those numbers. And I'd say, okay, 12, right? That's the smallest thing that they can both multiply into. When I look at my variables, I have x squared and x, so it's got to be 12x squared, right? If I had just an x, it wouldn't work for the x squared. So I know that I need to make the bottom 12x squared. So my first rational expression will get multiplied by 3. Okay, and then my second one will get multiplied by 2x, top and bottom. Okay, because we know it needs to equal 12x squared. So when we're working with this, the thing I really want you to be careful of is that we actually have a binomial on the numerator here. So that 3 has to get distributed to both the 5 and the negative 6x squared. Okay, so I don't want it to be just negative 6x squared plus 15. It's got to be negative 18x squared plus 15. Okay, everything gets multiplied by 3. Okay, then on the other side we have 3 times 2x gives me 6x over 12x squared. Okay, so last but not least, when I look at this, I say, okay, negative 18x squared, I'll combine my numerators, plus 6x plus 15, all over 12x squared. Okay, so far it looks pretty good. We've solved it, but can we simplify it? Okay, so we always want to double check, can anything be factored? Can we take a GCF out? So automatically we should say, oh, okay, well 18, 6, and 15, I can take that negative 3 out if I want. Okay, so if I do that, that gives me 6x squared minus 2x minus 5, okay, all over 12x squared. And then once I've taken that out, that's even awesome because I can say, oh, okay, that leaves me with 4x squared on the bottom. Okay, so we would just have to be extra careful that when we're doing this, we say, okay, I'll write it up here. That negative is still there. Negative 6x squared minus 12x minus 5 all over 4x squared. Okay? So it's kind of all over the place for this one, but there's our answer right there. Let's do another example. Okay, so let's work on, let's do one like 5x plus 12 over x plus 6 minus 3 over x. Okay, so again, we want to look at this and we say, okay, is everything factored? Our denominator here is 5x plus 12. Is that factored? Yep, that looks pretty good. So first thing we need to do is we need to find that LCD. Okay, so both of my denominators have an x, so an x is for sure going to be part of it. But I also need that x plus 6, right? That's got to be included. Okay, so for my first one, I would say, okay, well, x and x plus 6, that looks pretty good. But my second term needs it to be multiplied by x plus 6 on the top and the bottom. Okay, so when I look at this now, I'm going to start simplifying it. So my first term hasn't changed at all, right? 5x plus 12 over x plus 6. And then on this side, I'm going to have minus 3 times x plus 6 over that common denominator, x plus 6 times x. Okay, so when I look at this now, the first thing I want to do is I want to get rid of the brackets only on the top. Okay, so I don't want to take out the brackets on the bottom. I want to keep that in factored form because maybe at the end I could cancel something out. But for my guys on the top, I want to get rid of those brackets. So I have 5x plus 12 over x plus 6. And it's going to be minus 3x plus 18 over x and x plus 6. Okay, so the one thing I want you to really notice is that when we're doing this, imagine we have little invisible brackets around this binomial. Okay, so that negative, the minus, isn't just going with the 3x, our 18 is also getting subtracted. Okay, so for my next step, when I have 5x plus 12 minus 3x, it needs to be a minus 18. Because if I look at it, I can even imagine how, okay, minus 3x minus 18. I don't want a minus 3x plus 18, right? That doesn't even make sense. We're subtracting it. Okay, and then I have x and x plus 6 on the bottom. To finish up my simplification, I have 5x minus 3x. That gives me 2x. 12 minus 18 gives me 6x, negative 6x. Okay, so I've solved it. Now I need to simplify and see if anything else cancels out. So we have 2x minus 3. I took a GCF of 2 out. X and x plus 6. Okay, so nothing simplifies there. So that's my final answer. But then for full marks, I still need my NPV, so I know x cannot equal 0 or negative 6. Okay, so that's a couple examples of the adding and subtracting rational expressions.